Hello guys, welcome to the DMS online school. If you're new to this channel, you are most welcome, and on this channel I teach mathematics, science, biology, civic education, English, and also revise past examination papers. So in today's lesson we are going to look at a chemistry lesson where I'll be looking at the topic, which is the more concept. So be looking at the more concept. This is the best lesson that you will ever watch online. So all I ask from you is to give this video a like and also subscribe to the channel and also comment in the comment section. Without further ado, let's go straight into the lesson. So what you must understand here is that the more concept is a fundamental idea which deals with determining the amount of microscopic entities such as atoms, molecules, ions, or particles in chemical reactions and substances. That is it. So the more concept is just a fundamental ideas which deals with the determining amount of very small entities or microscopic entities such as atoms, molecules, ions, or particles in chemical reactions and substances, because the more concept is the only way that we invented as human beings to enable us to find the mass of atoms, which are very, very small. Okay, so in more concept, amount of substances are determined in the mole itself, which is symbolized by N, also relative atomic mass, which is symbolized by A subscript R, and also relative formula mass, which is symbolized by RFM, and also relative molecular mass, which is symbolized by RMM, and also molar mass, which is represented by MM. So these are the various forms in which amount of substances in mole concept are determined. Now let's begin this lesson by looking at what the mole is. Very important. So the mole, as it is represented by N, what is the mole? How do you understand by the term mole? So you must understand that a mole is the amount of a substance that contains the same number of elementary particles as there are atoms in exactly 12 grams of carbon 12 atom. What does it mean? A mole is just an amount of a substance that contains the same number of elementary particles as there are atoms in exactly 12 grams of carbon 12 isotopes. What it means is that 12 grams of carbon 12 has already been known the amount of particles which are there. So that amount of particles which has already been known to be in 12 grams of carbon 12 atom, that amount is also equal to a mole. Okay, here we go. So we are saying in 12 grams of carbon 12, there are 6.022 times 10 to the power 23 elementary particles. Yeah, so that is already determined. If you have 12 grams of carbon 12 atom, then you must know that in that 12 grams it has 6.022 times 10 to the power 23 elementary particles. So we are saying this means that if you measured a piece of carbon 12 atom to be 12 grams, it means that in that 12 grams of carbon 12 there are 6.022 times 10 to the power 23 elementary particles, and that 12 gram is equal to 1 mole of carbon 12 atom. That's what you should do understand. If you have 12 gram, then in that 12 gram, if you have 12 gram, you must know that that 12 gram is equal to 1 mole of carbon 12 atom. All right, so here we go. So if we have 1 mole of carbon, C stands for carbon, then you must know that it is equal to 6.022 times 10 to the power 23 elementary particles of carbon. that also is equal to 12 gram of carbon atom. So if you are given 1 mole of carbon, know that in that 1 mole of carbon there is 6.022 times 10 to the power 23 elementary particles of carbon, and also that same 1 mole is equal to 12 gram of carbon. So examples of these elementary particles that we are talking about are atoms, ions, and the molecules. So atoms, ions, and molecules are what we call elementary particles. So you must understand that if we have 1 mole of carbon, just as we have said, it contains how much? 6.022 times 10 to power 23 atoms or ions or molecules of carbon. So if they've told you that you have 1 mole of carbon, then they ask you to say how many atoms of carbon are there in that 1 mole. It has 6.022 times 10 to the power 23 atoms. In the same way, if they ask you to say you have 1 mole of carbon, how many ions of carbon atoms are there? You can say it has 6.022 times 10 to the power 23. Or if they ask you to say how many molecules of carbon are there, you can say there are 6.022 times 10 to the power 3 molecules of carbon. In the similar manner, if you have 12 grams of carbon, it also has 6.022 times 10 to the power 23 atoms or ions or molecules of carbon. Why? Because these two are related. So 1 mole of carbon is related to 12 grams of carbon also, which are related to this number here. These are the things that you need to understand under mole concept. So in short, you must know that a mole is an amount of a substance that contains 6.022 times 10 to the power 23 elementary particles. So if you fail to define a mole using this formula here, you can define it using this formula as an amount of a substance that contains 6.022 times 10 to the power 23 elementary particles. So let's push this one up here. So what you must understand is that this number 6.022 times 10 to the power 23 is called Avogadro's number or constant, which is symbolized by N subscript A in honor of Amedeo Avogadro. So Amedeo Avogadro was a scientist that invented this concept about mole. Okay, he equated 1 mole of a substance to 6.022 times 10 to the power 23 after doing some calculations which are not part of this level or which are beyond this level. So in counting, a mole is similar to a dozen or tray or pair. Okay, we know, for instance, a dozen represents the number 12, a tray represents the number 30 or 24, and a pair represents the number 2. In the similar manner, a mole represents the number 6.022 times 10 to the power 23. Okay, now what am I trying to say here? I'm trying to make you understand that as we use this normal English language, when we say a dozen, when you are told go and buy a dozen of batteries, they've told you go and buy 12 batteries. When they tell you go and buy a tray of eggs, they've told you that go and buy 30 eggs. When they've told you that go and buy a pair of shoes, you come with 2 shoes, the right and the left one. In similar way, when we say a mole in chemistry, we mean 6.022 times 10 to the power 23. So a mole can be used to find one number of particles in a substance, that is to say element, compound, or molecule. It can also be used to find the mass of substance either in element or compound. Okay, So let's push this one up here. So a mole can also be used to find the concentration of a substance in element or compound. Okay, so you must understand that the following formula relates the mole, elementary particles, and Avogadro's number. So we have this formula, which means number of moles is equal to X over Na. So where N stands for number of moles in MOL as units, and X number of elementary particles, and Na is Avogadro's constant, which is 6.022 times 10 to the power 23. So this is the formula now which connects the number of moles, number of elementary particles, and also Avogadro's constant. Okay, so that is what you must understand. N here stands for number of moles. What are the units for moles? It is MOL. Okay, then X is number of elementary particles, then A stands for Avogadro's constant. So this formula is very important in mole concept. We continue. Now let us look at some examples. So this is example 1. So this example 1 says how many atoms are there in 0.5 moles of carbon dioxide. Then number 2 says how many atoms are there in 2 moles of hydrogen gas. Then number 3, how many moles are there in 3 times 10 to the power 23. Okay, number 2 was how many atoms are there in 2 moles of hydrogen gas. Then number 3, how many moles are there in 3 times 10 to the power 23 molecules of carbon dioxide. Then number 4 says how many ions are there in 0.5 moles of sodium chloride. And then number 5 says how many moles are there in 1.8 times 10 to the power 24 sulfate ions. So very, very important that we start now answering these questions. So let's look at the solutions first of all. So we'll look at the answers for question number 1, which was about how many atoms are there in 0.5 moles of carbon dioxide. Now you see they are asking us to find atoms, right? Atoms. So now we see the formula. Now we remember the formula, which says number of moles is equal to elementary particles over Avogadro's constant. So at this point it's very important to write the data. So we have the data here. Data is the information given in the question. So you have been given number of moles as 0.5 moles. Where is it? Here it is. Then you have been asked how many atoms. So atoms stands for elementary particles, X, meaning that we don't know. So you put a question mark because that is what we are going to find. Then we also know that we have Na, which is always 6.022 times 10 to the power 23 atoms per mole. Now I must explain why I have put atoms per mole. You see, we have been given number of moles and then we have been asked to find the atoms. So it means that Avogadro's number has atoms per mole as the units. So what we are going to do first of all is to make X the subject of the formula, because that's what we are going to find in this case. So say X is equal to number of moles times Avogadro's constant. So X is just number of moles times Avogadro's constant. Then the next thing is to say X is equal to substitute number of moles is 0.5, then times Avogadro's number is 6.022 times 10 to the power 23 atoms per mole. Then we'll say equals, then we'll multiply. So once you do the multiplication here, you'll get 3.011 or 3.011 times 10 to the power 23 atoms. Okay. So that is the answer here. Now, according to how many decimal places? According to 1 decimal place, because the value given here has got 1 decimal place. So that is the answer there. So we move from there. So now, next we are going to look at the question number 2 here, which says how many atoms are there in 2 moles of hydrogen gas? The same formula applies. Number of moles is equal to number of elementary particles, which represents atoms, ion, molecules, over Avogadro's number. Then we'll also put the data, which is the information given in the question. So we have data here, number of moles we are given 2 moles. Then X, which is elementary particles, is the number or is the atoms that they are asking us to find. So this is question mark. Then Avogadro's number is always 6.022 times 10 to the power 23 atoms per mole, again because we have atoms here and moles here. So these are the units that are going to be on Avogadro's number. From there, since we are asked to find this X here, we'll make it the subject of the formula. Why do I know that it is X? Because X is the number of elementary particles, and we said examples of elementary particles are atoms, ions, and the molecules. And when they say how many atoms, they are asking for X. So when we make X the subject of the formula, it is going to be X is equal to number of moles times Avogadro's number. So say X is equal to number of moles is 2 moles times Avogadro's number is 6.022 times 10 to the power 23 atoms per mole, which will give us now 1.2044 times 10 to the power 24 atoms. Now, since our value here has no decimal number, so this one can be rounded off even to the answer is 1 times 10 to the power 24 atoms, like that. Okay, so now this more and that more cancels. That's how come we have atoms. You see, the question says how many atoms, and your answer should have units as atoms according to what they are asking you. That's why we add this, so that it helps you in arriving at the correct number of or at the correct units. Then we move to question number 3, which says how many moles are there in 3 times 10 to the power 22 molecules of carbon dioxide. So what are they asking you to find? They're asking you to find moles. So the same formula applies. Number of moles is equal to number of elementary particles over Avogadro's constant. So we'll put our data as usual. Number of moles. Are we provided? No, that's what they're asking. How many moles? So we'll say this is what we are going to find. Then we have been given 3 times 10 to the power 22 molecules. That is the number of elementary particles they've given us here. Then Avogadro's number is always a constant, which is 6.022 times 10 to the power 23 molecules per mole. Look, it has changed. We were using atoms per mole. Now we are using molecules per mole. Why? Because we have molecules given there. That's how this works. Okay, now from there we are going to substitute. So we are looking for number of moles, so the formula will remain as it is because N is already the subject of the formula. So it will be number of moles is equal to elementary particles is 3 times 10 to the power 22 molecules over Avogadro's constant is 6.022 times 10 to the power 23 molecules per mole. Then when you divide this, you are going to get 0.049817 mole. Okay, which we are going to put as 0.05 mole, okay, as the answer. Okay, so I have just rounded to one significant figure here because we have one figure here equal here. We can put this one to one significant figure. But if you want so that it is written in standard form, you can write this one as number of moles is equal to 5 times 10 to the power negative 2 moles. We have just changed this to standard form, and this is what I already taught in physics lesson. If you want to see this, how to do this, this is the mathematics lesson or physics lesson, and you have to join my online lessons. And if you want to join, you can just contact me on 0977 92 41 75 to join online tuitions, which are paid for. They are not for free. So this is the correct answer here. All right, so let's answer number 4. Now, how many ions are there in 0.5 moles of sodium chloride? So they are asking us to find ions. The same formula remains. So number of moles is equal to number of elementary particles over Avogadro's constant. So when they say how many ions, they are asking you to find the X, because the ions, molecules, atoms are elementary particles, and X stands for elementary particles. So what we are going to do is to put our data there. Data N is equal to 0.5 mole, because N is the number of moles that they've given us, because it is in moles, 0.5 moles. So N is 0.5 moles. Then X, which is the number of elementary particles, is what we are going to calculate. Then Avogadro's constant is always equal to 6.022 times 10 to the power 23 ions per mole. So we have changed ions because we have ions here. So we'll substitute, okay? So we'll make first X the subject of the formula, because that is what we are looking for. So say, okay, X is equal to number of moles times Avogadro's constant. So say, okay, X is equal to, so number of moles is 0.5 moles times Avogadro's constant, 6.022 times 10 to the power 23, like that. Then what we are going to do after we multiply that, we'll get the answer as 3.011 times 10 to the power 23 ions. Now, in sodium chloride is an ionic compound, meaning that it consists of 2 ions, sodium and chlorine here, sodium and chlorine. So this answer will further be multiplied like this. So we'll get the same 3.0 times 10 to the power 23 times 10 to the power 23 ions times 2. Sorry, here I should have multiplied this, not this one here, but that is okay. So the final answer now is going to be like 6.0 times 10 to the power 23 ions. That is the correct answer there. Then number 5, we have a question also which says how many moles are there in 1.8 times 10 to the power 24 sulfate ions. Okay, so to answer this, we'll say number of moles is equal to X over Avogadro's constant. So we'll say data, they've given us, they've asked to say how many moles, so we want moles, which is N, which is question mark. Then X, they've given us 1.8 times 10 to the power 24 ions, because those are elementary particles. Then Avogadro's constant is 6.022 times 10 to the power 23 ions per mole. So what do? We just substitute directly, because N, which we are looking for, is already the subject of the formula. So we'll just put number of moles is equal to 1.8 times 10 to the power 24 ions over 6.022 times 10 to the power 23 ions per mole. Then when we divide this, we'll get 2.9890 moles, but we can write this one to 1 decimal point, which can be 3.0 moles, okay, as our answer, and we can mark it like that. So this is your task key, which you can try here. Okay, so we have this task key, how many moles are there in 1.2 times 10 to the power 24 molecules of water. So try to answer this one, then try to put the answer in the comment section, and we'll be able to check and maybe later on stick or pin the correct answer in the comment section. All right, so please remember to give this video a like, and also let me know in the comment section if you have already downloaded the video. Go back to the channel and give it a like. That is the only way you can appreciate my effort of doing this. Otherwise, there's no any other way you can pay me. So let's now continue. So let's now look at determining mass of a substance. Determining mass of a substance, which in this case element or compound, using a mole. So you have seen moles. We have looked at different ways of calculating moles, how moles are related with the elementary particles and Avogadro's constant. And since we said moles are very important in determining mass of substance, so in this case, this is what we are going to look at. Okay, so we are saying in order to determine mass of an element or compound using a mole, the following concepts need to be understood. Yeah, so we are saying in order to determine mass of an element or compound using a mole, the following concepts needs to be understood. What concept do you need to understand? You need to understand relative atomic mass, which is represented by capital A subscript R. Then also relative formula mass, which is represented by capital M subscript small r. Then also you need to understand relative molecular mass, which is represented by capital M and the subscript small r. Then you also need to understand molar mass, which is represented by capital double M. So once you understand these concepts here, it will be very easy for you to calculate or determine mass of a substance. Now let's begin by looking at the relative atomic mass, AR. What is relative atomic mass? So the simplest definition of a relative atomic mass is that relative atomic mass of an element is the ratio of the average mass of atoms of an element relative of an element to 1/12 of mass of carbon 12. That is it. So relative atomic mass of an element is the ratio of the average mass of atoms of an element to 1/12 of the mass of carbon 12. So the point here is relative atomic mass is just a ratio where you compare relative, or where you compare average mass of atoms of elements to 1/12 of the mass of carbon 12. Okay, now what does that mean? Putting it in the formula, relative atomic mass can be written as average mass of atoms of a particular element over 1/12 of mass of carbon 12. 1/12 of mass of carbon 12. Now this is going to make sense very soon. So what it means is relative atomic mass can be represented by A, capital A, then small letter r, like that, which can be equal to the sum of, in brackets, you can have F1 times A1. By the way, F stands for fraction abundance, then A stands for atomic mass. Okay, then 1 stands for one element. Okay, so plus then fraction abundance of another atom times the relative atomic mass of that other atom, then plus the 3 dots means, and so forth and so on, then over then 1/12 of the mass of carbon 12. So this is the formula now. Now remember, these 12 and these 12 can cancel. So this is 1/12 of 12 of carbon 12. All right. So it could be that this formula may not have full information. Let me see. The relative atomic mass of an element is the ratio of the average mass of an element relative to 1/12 of the mass of carbon 12. Okay, so relative to 1/12 of mass of carbon 12. Now that carbon 12 has got 12 grams, the same carbon 12 we have been talking about. That's where this 12 is coming from. 1/12 is this one here, 1/12, it is 1/12. So 1/12 times 12 there, then this equals to 1. If you understand mathematics, 1/12 times 12, it will give you 1. 1 into that, you remain with the same. Now I explained here, I said where F and A are fraction abundance and relative atomic mass and atomic mass of the isotope in the sample respectively. So there are many like this because of isotopes. Again, if you want to understand this, you can look at you can join the online lessons for chemistry where I explained about isotopes and how to calculate isotopes. All right, so this formula now, because I've told you that this one will be 1, then the formula here reduces to relative atomic mass is equal to the sum of F1 A1 plus F2 then A2, then you put them in brackets like that. So we have said that AR has no units because it is a ratio of 2 masses and units cancels out. So because it is the ratio of other mass and other mass here, so the units cancels, so relative atomic mass has no units. So let's look at some examples here. So we have example 1 here, which says chlorine has 2 isotopes, chlorine 35 and chlorine 37. Chlorine 35 has a mass of 34.97 AMU and an abundance of 75.77%, while chlorine 37 has a mass of 36.97 AMU and an abundance of 24.23. Calculate the relative atomic mass of chlorine. Then number 2, the element chlorine is composed of 2 isotopes. About 75% of all chlorine atoms are 35 chlorine and 25% of all chlorine atoms are 37 chlorine. Find the relative atomic mass of chlorine. If you look at this question closely, it is just one question that has been brought in 2 different forms, and I'm glad that I'm presenting this question to you in this form so that you understand both ways in which the question can be brought. Because if I tackled it in one way and then the examiner bring it in the different way or in another way, you may be confused and conclude that you have never tackled about this question before or this concept before. Okay, so this is how these 2 can come. So let's look at the first one. So the first one is what we are going to look for. Since the question says here, calculate the relative atomic mass of chlorine, what we are going to do is to put down our formula. Relative atomic mass is sum of F1 A1 plus F2 A2 and so forth and so on. So this should be in brackets. Then we are going to put data down. Data is very important. Data is the information provided. So say data AR is relative atomic mass, which we are looking for. It is question mark. And F1, it is a fractional abundance of isotope 1. So we have this isotope here. Chlorine 35 has mass of 34.97 AMU, which is atomic mass unit, and an abundance of 75.77. This is a fraction abundance quantity. Fraction abundance is quantity given in percentage. So it is equal to, that is 75.77%. So that one, it is a fraction because percent means out of 100. Okay, so meaning we put it as a fraction, we divide 75.77 0.77% divided by 100, which will give us that fraction, which is 0.7577. We convert it direct, okay? Then F2 is the other fraction abundance, where they've said while chlorine 37 has a mass of 36.97 AMU and an abundance of 24.23. So this is the percentage abundance or fraction abundance of the other isotope. So it means it is 24.23 divided by 100, which will give us 0.2423. Then we are going to go for A1. A1, it is the atomic mass of isotope 1, where we are told 35, chlorine 35 has mass of 34.97 AMU. So this is the one it has, which is 34.97 AMU. Then they are saying while chlorine 37 has a mass of 36.97. So A2 here will be now equal to 36.97. all right, so having done that, we'll substitute these things into the formula where we'll say, all right, AR is going to be equal to, here F1, you see it is this value here, 0.7577. Then here between F1 and A1 there's times, so say times, then we'll put A1, which is 34.97, so 34.97, then plus here we'll drop the plus there. Then we have F2, which is this one here, 0.2423, then times this one A2 here, which is 36.97. Now this plus means that if you have as many isotopes as possible, you continue adding them, but since we have only 2, we end here. Then you evaluate this. After evaluating this using your calculator, you find that the answer will be 35.4546. Now we'll give this one to 1 decimal point or place where we'll have the answer is 35.5 there. Okay, now this was just time wastage. The answer here is 35.5 here. So this is the final answer here. Okay, so this is according to what we have been provided. This is the correct answer, because when you look at the values given here, they are recorded to 2 decimal points, 2 decimal point, 2 decimal point. So even your final answer should be recorded to 2 decimal point. Now on the periodic table, you'll find that it is 35.5 as the relative atomic mass for chlorine, because they rounded this one here. Yeah. Let's look at the example 2. Example 2 is another form in which the question can be brought on the same topic or same concept, where they are saying the element chlorine is composed of 2 isotopes. About 75% of all chlorine isotopes are 35 chlorine, and 25% of all chlorine atoms are 37 chlorine. Find the relative atomic mass of chlorine. So they have not given us any other information apart from this, so we'll say relative atomic mass is given by this formula here, data now, or say data. So we need to know AR, which is relative atomic mass, is question mark. All right, then we know that F1, which is percentage abundance here, it is the percentage for atom 1 or isotope 1, like 75% of all chlorine atoms are 35. So this 35 chlorine or isotope of chlorine has the percentage abundance of 75. So that 75 converted to a number, it will be 0.75. Then the next one here, F2, F2 is for the second chlorine atom or chlorine isotope, which is 25% of all chlorine atoms are 37. So the one with 37 has a percentage fraction or abundance of 25% over 100, which can give us 0.75. Now You can forgive me by putting these percentages here. Okay, they don't matter whether I put them or not, it's fine. Then next we need to find A1 and A2. So A1 here is just the atomic mass, relative atomic mass or average mass. So like this chlorine here, the mass it has is 35, this one here provided here. That's why it has been put in this form so that you understand, 35. Then this one A2, it's this one here, the second one, which has 37 here. Then what you do now, you substitute. So you say, okay, relative atomic mass is equal to, you get 0.75 as F1 times C, A1 as 35, then plus F2 as 0.25 times C, A2 as 37. Then you evaluate everything and you discover that your answer will be 35.5, just as we found in the first instance. All right, then we continue. So let's look at now what is known as relative formula mass. Relative formula mass represented by MR. What is relative formula mass? The relative formula mass is the sum of the relative atomic masses of all the atoms in an ionic compound. That is it. So relative formula mass is just the sum of the relative atomic masses. So it is just the sum. You know, when we say sum, we mean add, the total sum, meaning the add. So if you have a compound which is an ionic compound, which can consist of 2 or more atoms or ions, then the relative atomic mass is just, the relative formula mass is the sum of the relative atomic masses of those atoms in the ionic compound. So the relative formula mass is the sum of the relative atomic mass of all the atoms in an ionic compound. So you must understand that it has no units because it is calculated from relative atomic masses which do not have units. Okay, so those relative atomic masses which we have looked at do not have units because we said units cancel out. So let's look at example 2 here. So I mean example 3. So it says calculate the relative formula mass of the following compounds. We have A, calcium carbonate, then we have aluminium sulfate, then we have potassium sulfate, then we have also ammonium chloride. So let's start with the A here. So since the question says calculate the relative formula mass of the following compounds, we said relative formula mass is the sum of the relative atomic mass of all the atoms in an ionic compound. So in this ionic compound, which is calcium carbonate, it has atoms calcium, carbon, and oxygen, and these have got individual relative atomic mass. Where do we get these individual atomic mass? From the periodic table. Let me just show you from the periodic table here. So let's see if I can find the periodic table quickly. The periodic table, yeah, I have it there. So what we can do, if I were to look at this periodic table here, just this part of it. So when you look at the periodic table here, it has this number here. Okay, let me use this. It has this as the atom, and this number here is what we call the atomic mass, relative atomic mass, and this is atomic number. So it is these numbers here. Like for chlorine, what we did on chlorine, this is what we found there on chlorine. Remember when we did the calculation, this is what we found for chlorine. Let me just zoom it a little bit so that you can notice this one. So you see chlorine is here. We found 35.5 in those two calculations that we made. So we found the relative atomic mass from the calculations as this. So meaning each of these atoms here, the number which is up here, it is its relative atomic mass. Okay, yeah, so this is where they come from. Now, in the case of the question that we're looking at here, for calcium, let me show you. For here I said we have calcium, we have carbon, we have oxygen. If we were to come back to the periodic table here, you'd find that this is where calcium is on the periodic table. So calcium is this one here. Let me just put it here. So you have seen this is calcium, Ca, calcium. Its relative atomic mass is 40. Okay, then we go to C, which is carbon. Let me just move. C is carbon here. Okay, so C is carbon, carbon C here. It is 12 there. Okay, then O is oxygen, which is what? 16. Very important you know where I'm going to be getting these. I'm showing you because in the rest of the questions or examples I'll not show you now. So let's move on. So from there now we are saying this calcium here will put 40. We know that carbon, the relative atomic mass is 12 and the oxygen it is 16. Now since C relative formula mass is the sum, meaning we add them, so we'll say this is going to be equal to, you get 40, then plus 20, okay, then plus 16. Okay, now this 16, now see, just immediately after oxygen there's a 3. So this 3 means there are 3 atoms of oxygen. So since there are 3 atoms of oxygen, each of these atoms has the relative atomic mass of 16. So since there are 3 of them, we will not say plus 16 plus 16 plus 16. No, we'll just say times 3 there. Then when we evaluate everything here, we'll get the relative formula mass as 100. And it has no units, as I already stated. So we'll say, therefore, relative formula mass of calcium carbonate is 100. Then we got to B. B, we had aluminium sulfate like that. So aluminium, when you go on the periodic table, its relative atomic mass is 27. This is sulfur is 32. This is oxygen is 16. Then to find the sum, we'll say 27. To find the formula mass, relative formula mass, we'll say 27. Now it has a 2 here, aluminium, so you say times 2. Then we'll go inside here, we will go to 30 plus 32. Then since this S is inside the bracket, meaning this 3 affects oxygen, affects also sulfur. So sulfur is 32 times this 3 outside the brackets there. Then it is done. Then we'll shift to oxygen, we'll say plus. Oxygen is 16 there. Now because there's a 4 immediately, 16, we'll say times 4. Now because oxygen is also inside the brackets where outside of it we have 3, we'll say times 3. So when we evaluate everything here, we'll get 342. So say therefore the relative formula mass of aluminium sulfate is 342. Okay, then we move on to another one, which is the potassium sulfate. So on the periodic table, potassium is 39, sulfur 32, oxygen is 16. So say equals, so 39 times 2, so say 39 times that 2 there, then plus sulfur is just alone here, so it will be 32 plus, then oxygen is 16 times this 4 here. Then when we evaluate everything, we'll find that this will give us 174. Then we'll say therefore the relative formula mass of potassium sulfate is 174. Okay, then next we move to D, where we had ammonium chloride. So this N is nitrogen, which is 14 as its relative atomic mass. This H is hydrogen, its relative atomic mass is 1. Chlorine, its relative atomic mass is 35.5. Then we'll start adding. So this is alone, so say 14 plus this hydrogen has 1. Now there are 4, so say 1 times 4. then plus, then this chlorine is just alone, so it is just 35.5. Again, when we evaluate everything, we'll get 53.5. Then we'll say, therefore, the relative formula mass of ammonium chloride is 53.5. Next, we move on to look at relative molecular mass, which is MR, the same symbol. So relative molecular mass, what is it? Relative molecular mass is the sum of the relative atomic masses of all the atoms in a molecular compound or covalent compound. So relative molecular mass is the sum of all the relative atomic masses of all the atoms in a molecular compound or covalent compound. So what does it mean? It just means that when you have a covalent compound or a molecular compound, when you sum up the relative atomic masses of the atoms in that, then you get the relative molecular mass. Okay, so its calculation is similar to that of relative formula mass. So it has no units because it is calculated from relative atomic mass, which do not have units. Let's look at this example here. It says calculate the relative molecular masses of the following molecular compounds. A, we have ammonia, then B, we have water, then C, we have carbon dioxide. So let's look at the solutions, and then let's start with looking at question 1 here, which is ammonia. So we'll do the same since it is about the sum. So we'll just put nitrogen here is 14, then hydrogen is 1, then we'll sum it up. So we'll have 14, then plus 1 times 3. Okay, then we'll evaluate this. We'll have 17 as the final answer. Then we'll say, therefore, the relative molecular mass of ammonia is 17. Then we'll go to water. Water is actually H2O. So H is 1, then the oxygen is 16 as the relative atomic mass. Then here we'll say 1 times 2, then plus 16 because it is alone here. Then we'll evaluate this and we'll get 18 as the relative formula mass of water. Then we'll say, therefore, the relative formula mass of water is, molecular mass of water is 18, and they have no units as I earlier stated. So we'll move on to carbon dioxide. So carbon dioxide, which is CO2, carbon is 12 and oxygen is 16. So say equals, carbon is alone here, it will be 12 plus oxygen is 16. There are 2, so times 2. So when we evaluate everything, we'll get 44. Then we'll say, therefore, the relative molecular mass of carbon dioxide is 44. Okay. Next, let's move to look at molar mass. Remember, we are looking at determining the mass of a substance. I said you need to know relative atomic mass, relative formula mass, relative molecular mass, molar mass. So we have looked at these 3. Now we are looking at molar mass. So what is molar mass? Molar mass is the relative atomic mass or formula mass or molecular mass of 1 mole of a substance. Okay, yeah. So molar mass is just the relative atomic mass or formula mass or molecular mass of 1 mole of a substance. What that means is, if you have 1 mole of a substance, then its relative atomic mass or relative molecular mass. What I'm trying to say here is that if you have 1 mole, remember we have already talked about a mole here, so it shouldn't confuse you at this moment. So if you have 1 mole of an atom, then the relative atomic mass of that atom in 1 mole, it is going to be called molar mass. Or if you have 1 mole of an ionic compound, then the relative formula mass of that 1 mole of that ionic compound is the one that will be called molar mass. Similarly, if you have a covalent compound or a molecular compound, 1 mole of a molecular compound, then its relative molecular mass will be molar mass. That is what it is. That's why we are saying molar mass is the relative atomic mass or formula mass or molecular mass of 1 mole of a substance. And then you must understand that it is measured in grams per mole. Those are the units for molar mass, grams per mole. So molar mass, we are saying molar mass and the number of moles are related by the following formula. So there is a relationship between molar mass and the number of moles. This is the relationship. Number of moles is equal to M, which is mass, over mm, which is molar mass. So I've also explained to say where this n here is number of moles in what units, m or as its units. Then m is just measured in grams. So m is mass. Okay, so m is mass. So I should have put m here as mass, but sorry. So m, we can say mass measured in grams. Okay, so m, you say mass in grams, or you say m is equal to, you put mass here, measured, then we ignore this, in grams. Then that m is molar mass, okay, in grams per mole. These are the units for each of these. Now let's move on and look at examples here. Example 3. How many moles of carbon dioxide are in 200 grams of carbon dioxide? Number 2. How many moles of oxygen are in 32 grams of oxygen? So these are the questions here. Let's go through each one of them. So let's start with 1, which says how many moles of carbon dioxide are in 200 grams of carbon dioxide. So just put the formula here. Number of moles is equal to molar mass over molar mass. Now, how many moles of carbon dioxide are in 200 grams of carbon dioxide? Now, we will go for data. We have been given number of moles is what they want. How many number of moles? Question mark. Then we have been given mass as 200 grams. Okay. Then we need molar mass also here. So molar mass is going to be equal to what? 44 grams per mole. Now, where has this come from? From carbon dioxide. Remember, carbon dioxide, its formula is CO2. So this carbon here, we said it is 12, while this oxygen is 16. So we said the summation of it, if you say 12, then plus 16 times 2, then everything you put together, it will be 44. So this 44, which is the relative molecular mass of carbon dioxide, it becomes the molar mass for carbon dioxide. So you substitute in that equation where you say mass is equal to 44. Okay, I mean mass is 200, then over molar mass is, what is molar mass? Is 44 here, gram per mole. So what we are going to do is to say number of moles now is equal to 200 divided by 44, you get what? 4.5. So this gram and this gram will cancel, you remain with more there as the units. So we are going to say therefore there are 4.5 moles of carbon dioxide in 200 grams of carbon dioxide. The number 2, we had this question which says how many moles of oxygen are in 32 grams of oxygen. Okay, so the same formula, number of moles is that. So data is going to be number of moles is a question mark because that's what we are looking for. Then mass, we are given 32 grams. Then molar mass of oxygen is 16 grams per mole because oxygen is like O and it has 16 there. So it is 16. All right, as simple as that. The number of moles will be equal to mass is now 32 grams over molar mass is 16 grams per mole. So that gram and gram up will cancel. So remain with 16 into 32. It will be 2 then moles. So say therefore there are 2 moles of oxygen in 32 grams of oxygen. Then number 3 says how many grams of calcium carbonate are in 0.5 moles of calcium carbonate? Okay, so we'll use the same formula. Number of moles is equal to mass over molar mass. Data, we have been given mass as a question. Okay, they are saying how many grams, that is mass. Mass is question mark. Then we have been given number of moles as 0.5 moles. Then molar mass is going to be 100 grams per mole. Why? Because this which we have been given is calcium carbonate, and calcium carbonate is CaCO3. But you see how exam questions come and how people fail. If you don't know how to if you don't know that this calcium carbonate is like this, then you have already failed. Because I already taught a lesson in my online tuitions where I taught how to derive chemical formulas. If you don't know chemical formulas, then that is where you are going to fail chemistry from there. So for those that feel that they have a challenge in this, can you join the online lessons for science where they will be taught how to do this? They are very simple. Writing chemical formula, very simple. The way I teach, I make everything simple. So the line is 0977 92 41 75. That is the number you can call me or WhatsApp me. Now, don't call thinking that they are free. They are not free. Those are dedicated online tuitions. They are not free. What is free is what I bring on my channel here. What is not free is my dedication, my time that I give to teach you in my group so that you understand and pass. That is not free, because time is money. So if I give for free, when am I going to make money? When we came on earth simply to make money, because even in churches they pay money. So that is the reality of things here. I give you value, which is knowledge. You give me value, which is money. It's a win-win situation on earth. So now this is it. So calcium carbonate is 100. How? Because calcium alone is 40, carbon is 20, then 12, then oxygen is 16. Then everything, when you sum up 40 plus 12 plus 16 times 3, you get 100, like that. So now you substitute, you say number of moles here, it is 0.5 moles equals then mass, which is what you are looking for, over molar mass, which is 100 grams per mole. Then what you are going to do is to make M the subject of the formula, which will be equal to 0.5 moles times 100 gram per mole, like that. Then what you are going to do, so this mole and this mole will cancel. So what you are going to remain with is 0.5 times 100, which will be 50. Then you remain with a gram here. So what we are going to say is that therefore there is 50 grams of calcium carbonate in 0.5 moles of calcium carbonate. Then the last question, which is how many grams of ammonia are in 3 moles of ammonia. So put the formula as number of moles is equal to mass over molar mass. Data again is equal to mass is what we're looking for, then number of moles, we are told it's 3 moles. Then molar mass of ammonia is 17 grams per mole, because ammonia is NH3, then nitrogen is 14, hydrogen is 1, then we'll sum it up, 14 plus 1 times 3 there, because there are 3 atoms of hydrogen, will get 17. So you substitute where there's number of moles in the formula, you put 3 moles is equal to mass, we don't know, over molar mass, which is 17 grams per mole. So you make mass the subject of the formula, so it is going to be 0.3 times 17 grams per mole. Then that mole and that mole will cancel, so you multiply 3 times 17, you get 51 then grams. Then you say therefore there is 51 grams of ammonia in 3 moles of ammonia. All right. Then we move on and look at determining volume and concentration of a substance. Determining volume and concentration of a substance. In this case, element or compound using a mole. So a mole is very important. So we are looking at it as in determining volume and concentration of a substance. So you must understand that the volume, concentration, and the mole are related by the formula below. So C, which is concentration, is equal to number of moles over volume, where I have explained that this C is concentration of a solution. Then N is actually number of moles of a solute. And then V is volume of a solution. Okay. So what is concentration by definition? Let's look at concentration then. Concentration is the number of moles of a solute dissolved in a volume of a solution. That is what we can simply say what concentration is. Concentration is the number of moles of a solute dissolved in a volume of a solution. In other words, we can say concentration is number of moles of a solute per unit volume of a solution here. So concentration is the number of moles of a solute per unit volume of a solution. That one is also a standard definition. So the SI unit is the mole per cubic decimeter, or molar, which is capital M. So these are the SI unit for concentration, either this one or molar, which is capital M. Let's push this one up here, and now let's look at more detail. So here we are saying here it means that volume is measured in cubic decimeters. So volume must be in units called cubic decimeters. Very important for you to understand. So let's see how to do these things here. So let's look at an example here. So this is an example which says suppose you have 2 moles of sodium chloride dissolved in 0.5 cubic decimeter of water. Calculate the concentration in mole per cubic decimeters. 2, you have 0.8 moles of sulfuric acid and want to make 0.2 molar solution. Calculate the volume of water needed to dilute the acid. Then 3, you have 5 grams of potassium nitrate dissolved in 250 cubic centimeters of water. Calculate the concentration in mole per cubic decimeter. Then 4, you have 250 cubic centimeters of a 0.4 molar solution of hydrochloric acid. Calculate the number of moles of hydrochloric acid in this solution. So let's start answering these one by one. So we are starting with this one. The question is calculate the concentration in mole per cubic decimeter. So we'll put the formula here where we'll say concentration is equal to number of moles over volume. Let's look at the data which is given. Data we have, concentration is what they're asking us to find. So question mark, the number of moles, we have it here. They've given us, suppose you have 2 moles. So 2 moles there is 2 mole. Then volume, we have been provided volume, right? Which is 0.5 cubic decimeter. So volume is just 0.5 cubic decimeter. So we have everything to start answering. So say, okay, concentration, which is C, is equal to number of moles, 2 moles, over volume, 0.5 cubic decimeter. So you say concentration is equal to, then you divide 2 divided by 0.5, you get 4. Then you get more there, this more here, you put it here. Then this line becomes per, like that. Then you put it decimeter cubed, like that. So this is the answer here. So concentration is that one there. You can put either in these units, which what you were asked to find, but you can also put it in this. But if the question has specified that put the units like this, so the correct answer is this one. Here is another way you can write it, but don't write in units if they have specified. If this question just said calculate the concentration, then it's fine, you can put this one or this. But if it has said in mole per cubic decimeter, then you're going to put this to show that you know. Then you will not get the answer correct. You may get the process correct. If the answer requires that you are given 3 marks, you just get 2 marks. The final answer, which requires another mark, they will not give you for not following instructions. So I've just put this one to show you that this can also mean that, but the final answer for this question is this one here. Okay, so let's do number 2 here. Number 2, you have 0.8 moles of sulfuric acid and want to make 0.2 molarity solution. That is concentration now. Calculate the volume of water needed to dilute the acid. So we'll just say concentration, the formula is number of moles over volume. Data given is concentration is 0.2 molar. Then number of moles is 0.8 moles. Then volume is unknown. So we'll just substitute where this concentration, we'll put 0.2 molar equals where this number of moles 0.8 moles over volume we don't know. So we'll make volume the subject of the formula, which will be volume is equal to then 0.8 moles over 0.2 molar per. Okay, that one we have converted now this one nicely. So this one represents mole per cubic decimeter. Okay, then volume is now going to be, so we'll divide now 0.8 divided by 0.2 will get what? 4. Then this mole and this mole will cancel, will remain with the decimeter cubed. So meaning the volume which is needed is 4 cubic decimeter, because they said calculate the volume of water needed to dilute the acid. So this is the volume. Okay, then we move to another example, which is 3. You have 5 grams of potassium nitrate dissolved in 250 cubic centimeters of water. Calculate the concentration in mole per cubic decimeter. Okay, we understand concentration is this number of moles over volume. Data, what are we given? Concentration is what we are going to answer here. So it is a question mark. Number of moles not given. Do we have number of moles? No. As you can see, there's nothing talking about number of moles here. So it's question mark as well. Volume is given, which is 250 cubic centimeters. Then when we reach here, we need to use other knowledges that we have to find number of moles here. Can number of moles be found? Yes, using number of moles is equal to mass over molar mass. So this concentration we are looking for is for potassium nitrate that has been dissolved in 250 cubic centimeters of water. So this potassium nitrate is a solute. Okay, so since it is a solute, we need to know its number of moles, and when we know its number of moles, we will know the number of moles that will be in that 250, and that will be the concentration. So we'll know the molar mass here for this potassium nitrate. Now this is potassium nitrate, so the molar mass will know it is 39 here. Potassium, nitrogen is 14, oxygen is 16. So everything, when you total up everything, you get 101. So you start substituting, because number of moles will be equal to mass, which is provided here. Mass is 5 grams. So push 5 grams there over molar mass is what we have found here. Okay, so meaning number of moles now, number of moles is going to be equal to 5 divided by 101. It is going to be 0.04950 moles. Now you know number of moles, so you go ahead and start calculating. Concentration is equal to number of moles is 0.0495 moles. Okay, over then volume. This is the volume. This volume should be in cubic decimeter, as I said earlier. Remember, in science, forgetfulness is an enemy of science. If you do forget very often, then what I can advise you is to practice to remember. Because if you are not going to practice to remember, you are destined to fail. A person who forgets cannot succeed in passing. You can't. So what you can do is practice more. That is the nature of the brain. Some brains can remember, some brains can't. So those brains which can't remember, the only way to help those brains is to practice over and over and over. That is it. If you can't do that, just know that you are doomed to fail. Yeah. So now here volume, convert it into cubic decimeter by dividing this by 1000. When you divide this by 1000, which I explained by detail in the lesson, in the online lessons, how to do that. So you have this 0.02 0.25 cubic decimeter when you divide this. Then what you are going to do is to say now 0.04950 divided by 0.25, you get 0.198 mole per cubic decimeter. So meaning that the concentration, we can now put it as 0.98 molarity, like that. So this is the final answer, but we can also put it in this way. Then let's do this one here, which says you have 250 cubic centimeters of a 0.4 molarity solution of hydrochloric acid. Calculate the number of moles of hydrochloric acid in this solution. Okay, so number of moles or concentration is number of moles over volume. So data we have concentration, we are told 0.4 molar. Then the number of moles is what they're asking us to do, calculate the number of moles. Then volume, we are given 250. So it will be simple. Concentration, put that one there, equals number of moles you don't know. Volume, convert this one by dividing by 1000, which will give you 0.25 cubic decimeter. So make n the subject of the formula. So n will be equal to this one, 0.4. So this one changes to mole per cubic decimeter, then times this one here, 0.25 cubic decimeter. Then it is going to be equal to, when you see this and this will cancel, so you remain with more. 0.4 times 0.25, you get 0.1, then you remain with more. So as the answer. Okay, the last question I think. All right, so we go to the last part, relationship between volume and moles of gases. Relationship between volume and moles of gases. Okay, so we are now looking at the relationship between volume and moles of gases. So you see that moles continuously proceed from one substance to other, or from one quantity to another. We are looking at volume and moles of gases now. So here we are saying Avogadro's law states that the volume of a gas is directly proportional to the number of moles of gas, as long as the pressure and the temperature are constant. Yeah, that is Avogadro's law. It states that the volume of a gas is directly proportional to the number of moles of gas. What does that mean? It means that when the volume increases, the number of moles should increase. When the volume decreases, the number of moles should decrease, as long as the pressure and the temperature are constant, are not changing. That is what Avogadro's law states. Then we continue to say, this means that equal volumes of different gases at the same temperature and pressure contain the same number of molecules. So if you have equal volume of gases, let's say we have nitrogen, we have oxygen. If we have 20 cubic decimeter of oxygen and 20 cubic decimeter of nitrogen, in those 20 cubic of each, there will be equal number of molecules. That is what it means here. So we are saying this means that equal volumes of different gases at the same temperature and pressure contain the same number of molecules. Yeah. So the volume occupied by 1 mole of a gas at a given temperature and pressure is called molar volume. Okay. The volume occupied by 1 mole of a gas all right, so the sentence here wasn't correct. So the volume occupied by 1 mole of a gas, so you ignore this given here, of a gas at a given temperature and pressure is called molar volume. Okay guys, we have come to the end of this lesson. It has been a wonderful lesson. To complete this lesson, you have to join my online lessons where I completed this lesson. Thank you for watching. If you haven't subscribed to this channel, consider clicking the red subscribe button. If you have already downloaded this video, go and subscribe to the channel so that you are updated of other videos that I may upload in the future, which will be very important to you. All right, so thank you very much. As for now, bye, and see you in the next lesson. Peace.